Okay, you guys, we're here to do one more section in chapter 10. It's been a long chapter. There's not usually 8 sections, I know, so we're almost done. So we're going to do section 10.8, page 684. And let's get started and get it done. So remember, we've talked about several different types of lines or equations in this book. We had linear, which just made on your graph like a straight line, right? It's just a line, it's linear. Y equals mx plus b was an example of that. Then we had exponential, which kind of did this and then like whoosh, really straight all of a sudden, because when you're multiplying and multiplying and multiplying and multiplying, right, it gets exponential really fast. And then we also had quadratic, which were the ones that are parabolas, okay? So the first part of our assignment just wants us to identify which one is which. Make sure we remember. So example number 1, A is a picture that looks like this. So for A, I would write that that's an exponential function, and that's all I have to do. I just have to tell which kind it is, okay? B looks like this. It's just a line, so you would write linear. And C looks like this, which is a parabola, which goes with quadratic equations. So you would just write quadratic. So for problems like example 1, they just want you to identify which kind of line is it, which kind of equation is it. And those are your 3 options there at the top of 684 if you forget. Linear, exponential, and quadratic. Okay? Now sometimes they don't give us a picture, and so it gets a little harder. So let's look at example number... Well, before we look at example number 2, let me tell you how to tell the difference. I think that would help, which is what I have written up here already, which is on 685 at the top of the page. Okay. If you have a table of values and you're trying to figure out which one it is, there's a couple just tests that you run to see which one is which. The first one we're going to talk about is linear, okay? When you look at a table of values to see if it's linear, what you can do is you can find the difference between all the y's. So the difference between 2 and 5 is 3, right? It's okay if it's negative, positive. It doesn't really matter quite as much as just figuring out what the distance between the 2 numbers is, okay? So that's 3. What's the difference between 5 and 8? Also 3. And the difference between 8 and 11? Also 3, right? So the space that's in between each of those numbers, or the difference, is 3 for each of those, okay? So if that's the case, then you will have a linear function, okay? So they wrote linear here as an example, okay? To test for an exponential function, you use ratios. Remember, a ratio is something over something. So to do a ratio, we just do this one over this one. So 0.5 over 0.25, okay? 0.5 over 0.25 is the number 2. I ran out of room, but I'll just put it right there, okay? Now let's do a ratio this way. Let's test it. 1 over 0.5. What's 1 over 0.5 if I reduce it? Also 2, okay? Then we're going to do this ratio right here, 2 over 1. If I reduce that, that's also 2. So because each ratio equaled the same thing, that would be an exponential function. They're ratios and they all have to be the same thing. This one over this one, this one over this one, this one over this one, okay? And our last test is quadratic, and this one's a little crazy. It's called, there's like a couple steps that we do with this one. So let's check our differences first. Remember, the difference between 5 and 2 is 3, right? The difference between... They did a 5 minus 2, okay? So the difference between 2 and 1 is negative 1. You went down 1. The difference between 1 and 2, right here, I want to make sure mine are the same as theirs. The difference between 1 and 2 is you went up 1. And the difference between 2 and 5 is that you went up 3. So that's our first differences. Now to see if it's quadratic, we do what's called the second differences. And we'll do that same thing again, or the second time, okay? So the change here, negative 3 minus 1, that changes 2. Here, that changes 2 again, right? And the change from 1 to 3 is also 2. So now that we see that all of these are exactly the same, they're called the second differences, then we know it's quadratic, okay? So those are your tests to figure out which kind of line it is when you're given a table of values. Or you can graph it, I guess, and draw it if you want to. But I know a lot of you... I know one in particular super loves graphing, so you'll probably do it that way. He'll definitely graph, but the rest of you can use these little shortcuts if you want. So let's look at example number 2. Use differences or ratios, which are the tests that we use, to tell if it's linear, exponential, or quadratic. So look at example 2a. They first did the differences, and they got 0, 2, 4, and 6. Well, they saw that that wasn't the same, so they're not sure if it's going to, they know it's not linear, so they're going to try and go ahead and go to the second differences to see if those are the same. So they did the second differences and got 2, 2, 2. Because they were all the same, they were able to say it was quadratic. Okay, let's look at B. They did the differences of the y's right away, and they all happen to be the same thing, 3, 3, 3, and 3. If they're all the same thing, we can stop right there. We know it's linear. So these are just tests to see what kind of line you're going to end up with, okay? Let's look at page 686, example number 3. It says, tell whether the table is linear, exponential, or quadratic. So let's go ahead and do our tests. They did solution step 1. They found all the differences. They got negative 1.5, negative 0.5, 0.5, and 1.5. Now those are not the same. So they know that this is not linear. But they said, okay, we're going to try and do the second differences and test that. So then they went and did the second differences, which is this differences between that first set. Remember, we did that. And they got 1, 1, and 1. So since the second differences are the same, they know that it's quadratic. Okay, so they could answer quadratic. And then what they want to do next is write an equation for the function. Well, remember, quadratic equations have that x squared in them, right? They look something like this, and sometimes they have a b and sometimes they have a c. Okay, but when we're going to write our rules, we can just use this formula right here. Okay, so let's use example 3, the table at the top, to figure out our formula right here. Okay, y equals ax squared is our quadratic formula. Right there, you want to kind of keep an eye on that. So what is a y? Let's pick a y. They happen to pick 0.5. I don't have my table of values up here, but they picked the 0.5. So for y, they plugged in a 0.5, and then an a and an x squared. Well, we're going to leave our a. Then the x that goes with the 0.5 is 1 in our little table of values there, and we square it, okay? So in our table of values that they have for that example, they had a 1 and a 0.5 right there, and a 2 and a 2, and they had all the rest of this, but they used this ordered pair right here. So they put a 0.5 in as the y, and then they used a regular, and then the x was a 1, so they plugged that in there. They got that from the table of values, okay? So then they simplified. What's 1 squared? 1. 1 times a is just a, right? I don't really need to put a 1a, correct? Okay, so now I know that the a is 0.5. I can go ahead and write my equation again. Y equals, what's a? 0.5 times x squared. And now that looks like a quadratic equation, right? So when I have to do my equation, I go ahead and plug an x and a y in. Or if you were doing linear, it was y equals mx plus b, right? Plug your x and y in and get the missing part of your equation, and then just rewrite it. Your equation again with the missing part that you figured out, okay? I know I explained that really quickly. I know you may have trouble with some of these because they're a little strange when we have to go and write the equation that matches the box that we're looking at. So please give me a call, text me, FaceTime me. If you have any questions, I'm super happy to help as always. I really miss having you guys in here, and I feel like I'm not helping. So please just let me know if you need anything. Let's look at some directions on 688. 3, 4, and 5 are just matching. 6 through 11. You have to tell me if it's linear, exponential, or quadratic. You can graph those if you want, or you can make a table and figure it out either way. It says use a graph. I'm not requiring you to graph unless it's easier. Sometimes graphing is much, much easier because you could just quick put them on a graph and see what it does. So you can actually do them either way. It's up to you completely. 12 through 17, you can also do either way. If it's too hard for you to figure it out using this way and you'd rather graph it and see what kind of shape it makes, that's totally fine with me. I don't care which way you use. All right, so you answer linear, exponential, or quadratic, and then you have to write the equation. And that's where it gets a little confusing. Please let me know if you're getting stuck on these, okay? It's no problem. Remember, you can either graph or use the little shortcut methods on all the problems. I don't care which method you use. Do whatever one makes sense to you. Okay? Remember, exponential functions are like y equals a to the x, something that looks like that. Okay? If you need to, pause the video and take a screenshot so you have like all of this in like a little note form for yourself. And please let me know if I can do anything to help you. Okay? All right, we'll see you guys later. Bye.